or if I can find the right page, here we are. Let's put it on student view, that might make it more realistic. Okay, so this should be what Math 163 looks like. Do you notice that there's a new module, the final exam one? So I'll take you through this for a few minutes and then we'll be, pick your topics. So if you click on this one, it's a PDF and I'll make it as best I can, as big as I can. There. And we all know that our exam, it better be in this day or I'm actually, right off the bat. Our exam is on Wednesday, the 15th. Well, I'm glad I checked. I just put it on today, so I haven't had a lot of time to check it over yet. So our exam is going to consist of covering all these sections. That's from week 1 all the way to the last thing we did was the chain rule. Round about here was the midterm. So we're rough. Yes.
I don't see chapter 10 in here.
Did I miss that as well? Oh, God in hell. Right, let me take notes of this. Well, if I was going to miss one, chapter 10's the easiest one, isn't it? Because it's just got a section on sketching parametric and a little bit of what the derivatives look like.
That was the hardest part.
Okay, well, it will appear in there once I finally get around to fixing it. There's our link, and that one is correct because I recognize the last 3 digits. We have a special link for the final exam, so don't use your class one. And guess what? I did put the right date in, so I did it at least one place in the regex spot. Now, what you are and what you're not allowed to use, you can use any written notes you've got. You can, I would suggest you make as many useful notes as you can, but you have to organize them. And if you make too many notes, then in a funny sort of a way, it hurts you rather than helps you. Because if you have 40 pieces of paper you keep scanning through all the time, you're going to have a problem trying to find anything. So you might have 2 sets of notes in. You might have the big pile with everything, and then the little pile with all the key stuff, right? The things you know that you're going to need a lot of, right? So you are allowed those, so that's fine. What's going to disappear? Everything will disappear. If you go to WebAssign, there won't be anything there anymore. That'll have gone. That'll be visible up until sometime early on Wednesday, and then it'll disappear. So who knows, in the afternoon sometime probably when I get around to doing it. Everything in Canvas, including the videos, will disappear except that top one, which has Desmos in it and, all the bits and pieces you're allowed to use. There'll be one module left alive. And that's all you'll have as far as online goes. Your exam, of course, will be here now. Your exam will be here as well. But before I do that, click on that guy. There's the link that you're going to use. Do your final. Where is it? Oh, too late now. The final exam PDF is here. It better not be here. I'll be really annoyed with myself. Good. It's just an empty spot, but it will have the PDF of the final eventually. What else do you need? There. You click on this guy. You'll then upload, well, once I get it set up, you'll be able to upload your work into your final. You need help, Microsoft Lens, but you can use anything you want. The practice final solutions and practice final solutions large probably are a big overlap there, but there are some questions you can use. These 2 will disappear on the final for obvious reasons, but Desmos will be there. So you want to use Desmos to do stuff, there you go. And the other one after it, GeoBra. So if you want to do any 3D stuff, it could go there. So hopefully a lot of useful things there for you. That's the question. What we got? anything about this apart from the fact I need to fix chapter 10 and one of the bits on what you need to know PDF?
Is it true that the due date was extended to 9 p.m.?
We're here.
Yeah, for the final.
Yeah, there's a little bit of wiggle room. Some people get extra time as well, so it's really more for them.
All right.
You've got 3 hours, and then you've got that last half hour to get the photographs taken. And you know, if you're on the last question, you should probably use 10 minutes of it to do that. With a bit of luck, 3 hours will be plenty, I hope. Now, let's leave that. Jocelyn, you keep bouncing in and out. Are you here right now? No, she was getting problems. Probably in the same issue. Right. So we have a whole load of topics we could do. Questions, whatever. Section 1. 10 questions. Multiple choice. 5 points each. That'll get you 50 points. Section 2. We'll also have 10 questions, but these ones you'll show working as much as you possibly can, at least. And these are, on average, 25 points each, which gets you the other 250 points. So your final will be out of 300 points. It will be in chronological order. Question 1 from week 1, sequences and stuff. Question 10, chain rule. Question 1, sequences into series. Question 10, chain rule, right? So it's chronological. What else do I need to say? Drop dead date for all assignments is this Sunday midnight. I will be working on Monday to put together your last report. So I need everything finished so I can, compile it. On your last report, that'll be everything. There'll be nothing left to add except the final score. And I'll put in that final report, you need 120 points in the final to get a 2.0. You need 287 points in the final to get a 4.0. So whatever your goal is, at least you'll know what you need to do in the final to get that goal. So that will appear late Monday because I have classes to teach. Now, this is our last official day where attendance is going to be taken. Monday is a school day. Monday is going to be much more open-ended. So you can drop in Monday or not, you'll still get attendance. You might just drop in to find out how to do one topic because you've been studying, you're stuck. And then, oh, I got it, and leave. You can come at the middle and stay to the end. You can stay the whole time, whatever you want, right? It's totally open-ended. Do what you want. Come, stay, whatever. Any questions before we start our topics then?
Is it going to be like the midterm where we were able to use our notes and stuff?
Yeah, you missed that bit, but I did say it, yeah. You can use your notes.
Thank you.
Anything else, guys? Okay, has anybody got a topic, a chapter, whatever?
I had a question from
Go for
the practice final exam on question 11.
Okay, practice final exam. I'm just clicking on that so I know what it is. Question 11. Is that 11 in multiple choice?
Yeah. It was asking for the final position. I was just wondering, how do you think of it when asked such a question?
Okay, I think it's probably, since it's a very visual question, I'll put it on the screen and see if I can explain by pointing my fingers and imagining this question. Right. So are you looking at question 11, guys?
Yeah.
Right. Now, Imagine you're on this 3D Cartesian grid and you're at the point with coordinates 1, 3, 2. So 1, 3, 2. I'd be floating about here, right? So I'm facing upwards and that's where I am. And I'm facing the XZ plane, which means I'm facing this way here, right? Facing that way, right into it. I walk 3 units forward. If I walk 3 units forward, won't I hit the wall? In other words, my coordinates will now be 1, 0, 2. So far, so good. So I'm stuck to the wall with my nose on it at position 1, 0, 2. I then turn left. If you turn left, aren't you now facing in the x-axis direction? So I used to be 1, 0, 2, but now I've turned left and I've moved 2 units forward. So that takes me to 3, 0, 2. And that means I'm there. So really what that question is trying to test is your 3D awareness. Can you visualize in 3D? Can you imagine being in that thing there, that axis, and walking around it very simply, but still walking around it? And it's not a kind of question that you practice. And now that you've seen one, I guess you've seen one, but you know, I like to put in questions that are just a little bit different to get your brain moving, right? And that's a get your brain moving question. Okay, next question.
Anything with power series?
Anything with power series. There's a lot of stuff in power series. Let's see if I can find something. Have you got any particular preference? Because are we talking about radius and intervals of convergence? Are we talking about creating a power series from scratch?
Let's do creating a power series. I think I struggled with that one on the midterm.
Okay, let's, if you hold on a second, I'll go in and find one to do. It's better if you do. Well, no, I can make up on it. What am I talking about? If you're doing it from scratch, they're all bad. You know, there's no easy ones when you're doing them from scratch. Right. So, there are the one you're talking about, and then there's a kind of subgroup of that, which I'll do after this one. So suppose I wanted to do a power series of e to the 2x. And we're talking about Maclaurin series, so that means centered at 0. And the generic version of all Maclaurin's power series looks like this. And this funny notation with the little brackets around it, that means the nth derivative evaluated at 0, right? So what we need to do is just one job, but it's a difficult job. We need to find a formula that will tell us the nth derivative of this function at 0. So what we do is essentially, we start with this guy, we keep on differentiating them and evaluating at 0, and then we look for a pattern. And if we can see a pattern, that will allow us to get this guy. And once we've got this guy, we just replace this piece by the formula, because the other 2 bits are fixed, right? They're always there. So I'll start with f of x, and that is e to the 2x. And the value of that function at 0 is e to the 0, which is 1. And then I'll do the first derivative. And if you differentiate e to the 2x, you get e to the 2x times 2. And if you find the value of the first derivative at 0, you will get 2 times e to the 0. You will get 2. You then do the second derivative. Actually, this one's a lot easier than I thought it was going to be. You would get 2 e to the 2x times another 2, but do not do 4. Whenever you do these questions, write down the calculation, not the answer. So that would be, little squiggles means 2 squared. And so this guy ends up being 2 squared. And I'll do a fourth derivative. And if you differentiate this, you end up with 2 cubed e to the 2x. And the value of the third derivative at 0 ends up being 2 cubed. And hopefully you'll see a pattern, right? And if we can find a pattern, we should be able to come up with this guy. I might do a different one of this because it is a lot easier than I thought it was going to be. This is n equals 0, right? This is n equals 1, this is n equals 2, and this is n equals 3. So imagine what it would be if it was just n equals n. You notice a very simple connection. Isn't when you're looking at the third guy, it's 2 cubed. When you want the second, it's 2 squared. So you want the nth one, won't it be 2 to the n? Are we good with that? Now, since we found that one, I'm going to do another one after this. Is a bit easy, as I said. The power series is sigma n equals 0 to 8. The nth derivative now becomes 2 to the n, x to the n over n factorial. And that would be the end of that question. Okay. I'm not going to do any particular function. I'm just going to do patterns here. So suppose I had a function and I get this pattern. Oh, and let's make it even more interesting. Oops, that's a minus. So it goes plus, minus, plus, minus. Now you agree there's a lot going on in this one, right? So I need to figure out what the nth guy is going to guess, right? So we look at each piece and we try and see what's going on here. That one's very distracting because technically that's n equals 0. So I tend to skip that one and I look at the 1. The 1 gets me negative this stuff, e squared. 2 gets me positive this stuff, e cubed. And 3 gets me this guy, e to the 4. So I sit and I say, okay, let's focus on just one piece of the puzzle. Right? Piece of puzzle that's going to go here. First guy gets you e squared. Second derivative gets you e cubed. Third derivative gets you e to the 4. What's the nth derivative going to get you?
E to the n.
Is it n or more or less than that? 3 gets you 4. 2 gets you 3. 1 gets you 2.
Plus 1.
And plus 1, right? Now, some features you just pick up through experience. Isn't 1 times 2 times 3 times 4 also called 4 factorial? Well, or 1 times 2 times 3 times 4 times 5, that's called 5 factorial, right? So I'm going to put that guy as 5 factorial. This fella here is 4 factorial. This guy here is 3 factorial, and this guy here is 2 factorial. So we got the same problem. N is 3 gets me 5 factorial, right? The third derivative gets me 5 factorial. The second derivative gets me 4, and the first derivative gets me 3. There is a definite connection between the derivative and the factorial you get. So what will the nth derivative get me as far as the factorial goes?
N
N
plus 2
plus 2.
factorial.
You agree? N plus 2 factorial. And then we very often, but not always, don't we very often get plus minus thing going on?
Is that
And-
going to make -1 to the n because -1 to the 2 is going to be positive?
So -1 to the n is the one that makes this pattern happen. And if this one doesn't work, can't you do -1 to the n plus 1, which is the other guy, right? So you're always going to get one or the other. Now you've got this entire thing done then. You have broke the back of this question, right? But there's sometimes, there wasn't here, but there is sometimes going to be a little bit more work involved. The nth derivative ends up being that guy, x to the n, all over n factorial, right? Basically, if I cover that up, can you see the two fixed guys and this horrible mess here? That's him. Style points. Factorials do cancel with other factorials. They just kind of cancel in a little bit of a different way, right? This n factorial will kill off most of, but not all of the n plus 2 factorial. So I'm writing down now all the bits that are still there, right? If n plus 2 factorial had a fight with n factorial, the top would win. What would be left behind is the trick.
Is that x plus 1, well, sorry, n plus 1 and times n plus 2, because n plus 2, if I assume that should be, it also has an extra n plus 1 and an x plus 2 behind
Yes.
it.
Are you comfortable with that, or do you want to kind of see it in more detail, why this cancel leaves you with these two terms? Can you see it?
Can we go through that a little bit?
Say that again, Jessica?
Can we go through that a little bit?
Sure. Right. So if someone wanted us just to do this, right? So let's isolate that. If you write it out in full, n factorial just means 1 times 2 times 3 times 4, and you finish on times n, right? N plus 2 factorial is very similar, at least in the start. The only difference is you don't stop at n, you keep going until you get to n plus 2. Right, so after n, the next guy is n plus 1. After him, it's n plus 2. After him, it would be, I guess, n plus 3 until you get to wherever you stop. And now we do that kill, 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 kill. And you see the two guys that are left is the n plus 1 and the n plus 2, which is what we have here. We cool? Now, on this pattern forming, what do we call it, right? This thing here. It's okay to have these calculations. So I'm not changing anybody that much. And what's that? Plus, minus, plus, minus. It's okay of fractions, right? Now, based on what I've just done, wouldn't the nth derivative at 0 be almost the same thing that I just said? It's n plus 2. But wouldn't you put e to the n plus 1 on the bottom? So I don't care if it's on the top or the bottom, right? The pattern's the same, isn't it? The second, the first one gets you this, the second one gets you that, the third one gets you that. So you put it on the bottom instead of the top. If you put all of these underneath the factorials, wouldn't the only real difference be that this guy here, the e to the n plus 1, would now be in the bottom? Okay. Now there is a second kind of power series questions where you don't do any of this. You use somebody else's hard work. So you are told, or you go look it up.
That should be x to the 2n over 2n factorial.
Yes. Oh, you've memorized that one, right? Good. Right, that is the power series for cosine x, which is nice to know, right? So let's assume you know that, but you can use it to get the power series for that guy. And you don't need to do any of this differentiation. In fact, if you tried to do this differentiation, you would probably go crazy because the pattern wouldn't be obvious. In fact, I'm not even sure there is a pattern, right? So what you do is you think substitution. If I know this guy, I should be able to get power series for this guy. And all I would need to do is replace one piece of the puzzle. And the piece I'm going to replace is the x. And I'm going to replace it with x squared. Does that seem reasonable? You see what I did? Now, what about the x cubed? Yeah, the x cubed is there, right? It's a different situation, right? The x cubed just a multiplication. And then I'll take it a little bit slowly. You make it look pretty. That is not considered pretty. X squared raised to the power of n gets you x to the 2n. And last step, essentially, don't we bring this x cubed inside the sigma?
Wait,
all
is it supposed to be raised to 2n and not just
Yes,
n?
2n. X squared raised to the power of n gets you x to 2n.
Right, but the first one says x raised to 2n and then you replaced it with the x squared and it.
Oh, sorry. Well caught. 4n. Well caught. Yeah. X squared to the 2n gets you 2 times 2 is 4n. Yeah. And to finish with, you bring this guy in, and you are done. Right. That's a lot less work, isn't it? If you can use somebody else's power series, right? Somebody else found out what the power series for cosine x is, and you can use it now to do all sorts of combinations of them, right? Okay, maybe move on to something else then. That's unless you, I mean, we can spend all day on one topic if you want as well. But who's got the next topic or the next question? Oh, by the way, if you want to know what would it look like in a test, I would say to you something like, use the fact that cosine x is equal to find the power series of x cubed cosine x squared, right? You wouldn't be just left there hanging, thinking, will I do it the first way? Will I do it the second way? Now, if I didn't tell you any of that, then you would be doing it the first way, right? Okay, what's the next question?
23 of the final review.
Okay, that seems to be a good spot for us to do some. Are we talking section 2? Yes, we must be, I think. Question 23, did you say?
23 of the final reviews.
Okay, let's see. Is this the one, find the point of intersection of a line and another line? Is it that one?
Yes.
Okay, so question 23 has basically a line in 3D, and it's 2t plus 1, 3t take away 1, and t plus 5. And then there's another guy, q, and they're using the parameter s, which you should do. And you have 2 different lines, and you have an s. You have a 2s take away 5, and finally you have a negative s plus 12. And we are being asked to find the point of intersection. So we're told these 2 lines cross somewhere. So can you pretend that that's P, right? P of T. And this guy is Q of S. There is some point where they don't fly over each other, right? They actually cross. Now, the geometry tells me if 2 lines cross, even in 3D, isn't there only one answer? Right? There's only one place where 2 lines can cross, right? They can't bend around and cross somewhere else. So at least I know there's only one solution. Now, if you think about this point, P, I'll call it P. At the point where they cross, don't these 2 x coordinates have to be equal? And don't these two y coordinates have to be equal? And don't these two z coordinates have to be equal? Right? If they're going to cross, don't they have to share the same thing? So what I'm going to do is I'm going to take the x coordinates and say, okay, if they're equal, then 2t plus 1 has to equal s. And I'm going to take the y coordinate and I'm going to say those two also have to be equal. And I'm going to pause there for a minute. I only need two equations if there's two unknowns, right? I don't need to make my life hard by trying to compare the z's. Technically speaking, couldn't I pick any two that I liked? Because maybe two of them are nicer looking than the other one, right? It won't matter. The math will only find the one unique answer anyway, right? So we know we're going to be fine. They just came out that way. I don't know if I showed my solution that way, but they're fine. And if you're trying to solve two sets of equations like this, there's, oh God, Math 99 and Math 94 way back in the day. These are called simultaneous equations, right? Or system of equations is another name you might know them by. And you can do it by the addition method or the substitution method. I'm going to use the substitution method because isn't equation 1 already set up? It's telling me that s is 2t plus 1. So I'm going to go here and I'm going to go 3t minus 1 is 2 lots of s, 2 lots of that guy, take away 5. And now all I have is an equation in t. And as long as you do it to both sides, it's okay rule, isn't it? We've used that one a lot in our life. I guess I could tidy up a little bit. Okay. Right, tell me what to do next time.
Add one to each side.
Okay, that'll work for me. What are you going to do next?
You solve for t by just subtracting subtracting 4 to both sides.
Okay, you can go that way. And are we cool with t equals 2? Now, t equals 2 means that s is 2 lots of 2 plus 1. Doesn't that make s equal to 5? You see why I make those funny little marks on my s's? Because don't they look like 5s I've had on? Right. So s is 5 and t is 2. Well, let's go finding this point of intersection. If you use t equals 2, this vector will give you the position of the point at 2. It's 2 lots of 2 add 1, which is 5. 3 lots of 2 take away 1 is 5. And 2 add 5 is 7. Now, if I use s equals 5, and I use it in here, s of 5 will give me 5. 2 lots of 5 take away 5 is 5. And negative 5 add 12 is 7. Wasn't that kind of overkill? Because I only really needed to use the first one because there's only one answer. So it has to be that guy. So what are the coordinates of the point? 5, 5, 7. Make sense? There you go then. What's our next question?
Can you do the number 24 on the final review?
Okay, 24. Again, it's to do with straight lines in 3D space. We've got a line P. I think it's got a different equation. Is it the same guy? Yeah, they're slightly different. So, okay. So this one is 2t take away 1, t plus 1, t plus 2. And this one is s, 2s take away 1, and s. And the question could be guessed, but if you do, you'll get no points. because you have to prove whatever it is you decide. Are they parallel? Are they identical? Or are they skewed? Now, there could have been a fourth possibility, and the fourth possibility would be that they intersect. But since you're not given that one, that means you don't need to look for it, right? Because that's not one of your options. Right? If I gave you all four, you would have had to have checked that one as well. Now, if you think about what do two lines do in 3D space, well, can't they be parallel, right? Like this. Never meet, go on forever. Identical means that you end up with the same line. In other words, all the points on this line are on this line, right? They're embedded in Z, you know, one is the other, right? And now skewed is when one, if I turn the angle a little bit, right? They're not parallel, right? But they don't cross either. You see, they're a definite gap forever, right? The two jets flying, you know, by each other, but don't crash into each other. So when you are looking for this type of question, you kind of approach it in a kind of order. The first one you check is parallel. Now, if the answer is they are parallel, then you kick out skewed, because two lines that are skewed can't be parallel. You see, they're pointing in totally different directions. Now, if they do end up being parallel, there are two kinds of parallel. Couldn't you be parallel like this? And couldn't you be parallel because you're identical? So we're going to have to decide if that's what happens. So how do you check for two lines being parallel? You use their direction vectors. That's how you test. So if we look at P, right, that guy, its direction vector is 2, 1, 1. Are you comfortable with 2, 1, and 1, right? It's the coefficients of T. Now, what about the second vector, Q? Well, its direction vector is 1, 2, 1. Now, I can just eyeball it and tell you that they are definitely not parallel. If they were parallel, wouldn't one of them have to be a multiple of the other? Wouldn't this one have to be like 4, 2, 2, or -4, -2, -2? If you want to know the formal check, you divide corresponding components, and do you notice you get a different number each time? Actually, you only need to be two of them to be different. That means they're not parallel. Now, if you're not parallel, then that's off the list. If you're not parallel, that is off the list. You have to be skewed then, right? There's only so many things you can do in 3D space.
Could it be perpendicular?
Well, perpendicular is just a version of skewed. So it doesn't get any, you know, special name, right? Can you imagine these two guys are skewed, right? Aren't they also perpendicular if you look at them like this? But they're never crossing.
I meant, like, is there a way to tell, like, if they're perpendicular, they
Yeah.
are crossing?
No, they can be perpendicular and not cross. Where's my camera?
Well, I'm talking
Right.
about the version if they are crossing.
Oh, if they are crossing, even if they're not, you can tell if they're perpendicular. And won't you just take the dot product of each one? And what will the dot product be if they were perpendicular?
0.
0. And I can tell you right now, that's not 0, right? Just by looking at it. So they are skewed. And they don't go into any more detail, so I'm not going to do any more. If they wanted to know what angle did they make if you were looking at them from above, I guess I could do a dot product thing, couldn't I, and figure out what that angle was, but they're not asking for it, so I'm not going there. Okay, suppose they gave us the opportunity for intersect. If you were trying to find out if these intersect, you do the exact same thing I did over here. Remember we took the equations? I would have said this guy equals that, and then I'd say this guy equals that, and let's say 2 and 5 were my solution. If you plug t equals 2 in here, do you see you get the answer 4? If you plug s equals 5 in here, do you see you get a different number? So if the numbers are different, what you're looking at is not is skewed. If all three were the same, wouldn't you look at intersect? Skewed, intersect. Because the method for finding out where the potential intersection is the same method whether they are or not, right? You always match two of them and solve, and then see if the third one fits, right? So X and Y are always going to fit. It's whether the Z's fit, because well, can you imagine looking at this from above? Aren't they going to share an X and Y coordinate? Isn't the difference their height? Their Z's is going to be different if they're skewed, or if they're equal, doesn't that make them intersect? And now you've got all three values. Okay, where are we off to next? We need somebody else, I think. Not that Viet hasn't been given good questions, but just to give everyone a little bit of a chance. What have we got?
Should we review chapter 10? Quickly.
Review chapter 10? I'm going to put it in. You mean you've forgotten all about it? Okay. Maybe I haven't forgotten all about it, but I'm looking for chapter 10 right now so I can remind what we did. We didn't do too much. So there are a few things in chapter 10. Well, I'm getting myself kind of set up. Do you recognize that that would be a situation that would be a straight line in 3D? And you might be interested. Come on, where's chapter 10? Right, so you might be interested in some of the properties of this particular shape. What could I do? Okay, that's a straight line. Imagine I have a plane. Wouldn't we like to know, for instance, where does a straight line hit a plane? Equation of a straight line. That's what the equation of a plane looks like, right? They're quite different looking. Straight line is parametric, well, it's one of its versions. Aren't planes just a linear combination of x, y's, and z's? The problem was, what is the point where this line intersects, right? Touches the plane. How'd you do it? Tell me the math that you would use to solve that problem.
Would you plug the x, y, and z into the equation of the plane?
Yep. So instead of 2x, you get 2 lots of 3t. Instead of 3y, you get 3 lots of 2t plus 1. And instead of subtract a z, you subtract a 5t minus 1, and you make it equal 10. Now, I just made these up, so we could have a problem here. So let me tell you what can happen before we've gone any further. You could get 5t equals 10, in which case t equals 2, right? As an example. If that happened, don't you just plug it in here, here, and here, and now you know the point. It would be 6, 5, 9. You could get all the t's disappearing. Right? Everything on this side just killed everything off, right? And it doesn't need to be 0. You could get 5 equals 10. You could get 7 equals 10. But you've got this, no more t's left, right? We have to be able to interpret that, because it's not just we made a mistake, right? It is telling me something about this line and this plane. What does that tell me?
That they're parallel.
Yeah, it's flying above the piece of paper forever, right? It's paralleled. And the last possibility, you get 10 equals 10. That's a special case of this one, right? The t's all disappeared, but 10 is left on the left and it's equal to 10 on the right. That can and does happen. So what on earth does that mean?
Does that mean perpendicular? Like it goes straight down the plane?
No, if it was perpendicular, it would still intersect at one point, right? If you come in at an angle, which is more likely, you're still going to intersect at one point. That doesn't mean perpendicular.
Does it mean that it's on the plane?
Yeah, it's embedded on it. It's basically that red line, right? It's that pen on the paper, right? We could say it's embedded, right? It's like a car driving along the road. It's not an aircraft at all. It's not flying above the air, right? It's driving on there. Well, let's find out what we got. I have a 6t. I have a 6t plus 3. I have a takeaway 5t, and I have an add of 1, and that's going to equal 10. Well, that, and that gets me, I believe, 7t. And if you take away 3 and then take away 1 from both sides, you get 6. And it looks like we got a single solution, right? T equals 6/7. Hopefully I did that correctly. Yep. Yep. So what would the point look like? Well, if you plug T equals 6/7 in here, you get 3 lots of 6/7. You get 3 lots of 6/7. That's 18. 2 lots of 6/7 is 12 plus another 7, so that's 19/7. And you plug it in here and you get 29/7. So maybe not the prettiest point in the world, but that point P is actually 18/7, 19/7, and 29/7. Basically, a space curve is a vector from the origin to the point. So if you know that, it's equivalent to telling you the coordinate.
Should the third one be 23/7?
Could be, I can't count. Let's find out. 5 lots of that are 30. Take away 7. 30 take away 7. 23. We good? It helps if you know what is physically possible. See, in that story there, there's only 3 things that could really happen. Before I even talked about, the math of it, I'd be saying, okay, if I had a plane, so I'll use this guy. If I had a plane and I have a line, what's going to happen? If they did intersect, you can only do it once, right? Wouldn't it shoot right through and bye-bye forever, right? It could fly above it. So parallelogram. Oh, it could be on the plane. And that's it. I mean, that's the only 3 things that can happen.
Was that basically it for chapter 10?
No, they had a second group of questions. Well, at the beginning, they gave you the ones where you have to sketch it. But as long as you know how to use Desmos, can't you plug it in and do a sketch, or GeoBra do a sketch? I mean, if it's a 3D one, don't you just go 2t, 3t squared minus 1, 5t, right? And GeoBra will draw, the weird curve, whatever it looks like. No, the other thing we're doing is converting from parametric into Cartesian, right? So from t's into xy's, that kind of thing. So suppose you get x is equal to sine theta, and y is equal to I need something hard on that. Okay, that.
How do you do y equals tangent?
Yeah, well, you could, but some of them don't work. So if
Oh,
I did a
okay.
tangent, I'd have a sine and cosine. Well, I could maybe, no, I couldn't do that easily. Right, let's suppose I got this guy. It's not the worst looking one in the world. We need to convert this guy into an equation that uses x's and y's. The chances are it's not going to be y equals x cubed. The more likely is implicit, right? X's and y's all jumbled up with squares of each and so on. So when I've got trig, one of the strategies is I want to find the theta in this case, or it could be t the next time. I want to isolate and everything else that isn't over here. Now, if I take this guy, I'm going to do y take away 2, which gets me 2 cosine thetas. I don't want just a 2 cosine, so I'm going to get a cosine. And so I have this guy, and I have this guy. So this is the approach I would take if there was a sine and cosine involved, right? Now we have to figure out some way to make these two things play together in such a way that the thetas disappear, right? So the only thing that's left is some stuff over here. And I'm going to use a trig identity, which is a very common one, sine squared plus cos squared, which means I'm going to have to do some more work. So I'm changing color. If you square both sides, you get that. If you square both sides, you get that. Where do you think I'm going next?
Are you going to add the sine squared and cosine squared to become 1?
Yeah. So these two guys squared plus this guy squared equals 1. And it might not be the prettiest answer in the world, but haven't I now got an equation with x's and y's in it, which is all we were trying to get in the first place. Now that's what you do with trig, right? If there's a sine, a cosine, if there was a secant in the tan, I'd probably do something similar. But you can also get these guys. Right, so how do you approach questions that don't have trig, right? Don't have sines and cosines. Their approach is a bit different. What you do is you pick one of those two equations. Most of the time, there's probably going to be one of them that's a candidate, but occasionally you get lucky in both, that you know you can turn into a t equals. I'll call this equation 1 and equation 2. There's only one of those two equations that with a little bit of work, I could eventually make it t equals something. Now, where are we going? You're thinking 2. Is there a bit of a problem because there's 2 t's here? So I don't like that one for that reason. So let's do 1. Now, as long as you do it to both sides, it's okay though, right? So let's square both sides. That gets rid of the square root. Remember the goal, t equals. That's what we're going to get. What should I do to both sides next? I want to get, add 1. Yeah. Okay, almost there. What do I do to both sides now to get t?
Cube root.
Now, once you have got t equals, in this case, that horrible mess, you go to this equation, the one you haven't used, and you replace these guys by him. So you've now got the cube root of x squared plus 1 squared plus 2 lots of the cube root of x squared plus 1. And you can't really do much with that, but you can at least do this. And we got lucky this time, didn't we? We managed to get it in the form y equals. You don't always get that lucky. Now, back to this one. Can you see that that would be a bad candidate? If you try to make that t equals 2 t's, not a good way to go. Okay, where are we off to next?
Could you place the page back up?
Sure.
Number 36 of the final review. Is that possible?
Sure. Nobody else is asking, so why not? That must be pretty close to the end, as you say, or maybe even the end. Let's see.
It is like the end of the section 2.
Okay, so find all the first and second partial derivatives. Oh, okay. Now, when you're doing a question that's as big as this, because it is going to be big, because let's tell you what you're going after. The two first derivatives are going to be that. The second derivatives are going to be that one, that one, that one, and finally that one. Do you see that there's 6 different things, right? So anything at all that we can use to make our life simpler, shouldn't we do it, right? If, in particular, what you tell me about these two answers?
They're
They
the same.
share the same answer.
There. We're assuming that this is continuous, which most functions are. You're going to be able to get them. So if you get this one, couldn't you just put that one next door to it and you'll be fine, right? So to get these guys, including those two, don't you have to get this guy and or that guy first, right? So you can't avoid, you know, oh, I'll not bother and jump right into that. You need these two guys. So the partial derivative with respect to x of this function, well, if you differentiate, well, wind back, that y on the bottom is a constant if you're differentiating with respect to x. It's like sine xy over 2, right? That's all it is. So this is not a quotient rule. It's not a horrible question. It's just a weird 1 over y sine xy, if you want to think it like that. Now, if you differentiate a sine of xy, you will get a cosine of xy, obviously, still over y. But that is a chain rule, isn't it? Because the inside function is xy. And if you differentiate xy with respect to y, you get times y. Are you comfortable where that times y came from? And then a little style points. Agreed? Now, the other guy, the fy fella, I don't like him. I'm doing it over here at the side because he's going to take a fair amount of work. Since I'm differentiating with respect to y, this guy is a quotient rule. Agreed? I could bring this up and call it y to the -1 if you like, but both methods are equally ugly, so, you know, pick your poison. So I may as well leave it like that. So with respect to y then, it's going to be f dashed g, take away f of g dashed, all over g squared. Now with respect to y, if you differentiate this guy with respect to y, you're going to get x cosine of xy. Are you happy about where this x is coming from? Because you differentiate that, you get a cosine, and then the derivative of xy with respect to y gets you this x. Then you take away, leave this guy alone, and then you differentiate the bottom. Well, that's actually just 1, isn't it? And then over y squared. And I don't see anything in this that is coming out pretty. And I'll just leave it. I guess I could, I'm not even sure this is worth writing, but I'm doing it now. You agree? Now, that's both first derivatives done, right? So I'll put that answer over here. Now I have that guy to do. I got these two guys to do, and I've got that guy to do. Right? So let's do that one. Now to get this second derivative, don't we take this answer and differentiate it with respect to x, right? That's fx, do another x on it. Well, derivative of that guy is negative the sine of xy times the derivative of xy with respect to x gets me a y. Are you comfortable with that one? Now I'm going to do f of x, y.
Hey, Professor, I hate to interrupt, but I have a little emergency and I gotta get going.
Okay, sorry to hear that, Lewis. Make sure you say your last name before you go.
All right, have a great weekend.
You too. Right, so f of xy then. So we are going to take this answer and do a derivative now with respect to y. And you get negative the sine of xy. But when you differentiate the inside function with respect to y, do you see you get an x? They're kind of the same, but not exactly the same. Now, I can do this one for free. Which brings me to this ugly bugger. I could have done f of yx on this expression, couldn't I? And I would have eventually got the right answer. And as strange as it seems, it would have ended up being that guy. So can you see that sometimes the choice of which one you do can make your life easy or it can make your life hard? So we got lucky that that guy was nice and therefore this was nice. Can you imagine a world where I had this guy to pick from or that guy? Shouldn't you always pick this guy as your starting point for the XYs? Right. Now, if they're both equally ugly, forget it, right? You're going to end up in trouble. And I am too lazy to do the last one. But won't I have to take this guy here? And won't I call that top guy F? And won't I call the bottom guy G? And won't 10 minutes later, won't I get one of the ugliest looking fractions in the world, but that will be my answer. So a function that might look pretty balanced, can't you have easy questions and really ugly questions? And it just depends on which variable you're trying to differentiate with.
It's a question about the partial derivative with respect to y.
Okay, which one?
The first one.
Yeah?
Yeah. Something
Okay.
looked wrong with it because
Oh, I've made mistakes before. Let's check it out. F and G, F dash G. So you differentiate this with respect to Y.
wouldn't there be a y in the front because of the g?
Oh, there's another Y that I missed somewhere. F dash G, yeah. You've just successfully made it even uglier than it was a minute ago. So I guess that just emphasized what I said, right? Do it in this order. That one's just probably added another minute onto your working, but you're right. F dashed, forgot all about the G. I get that caught up in doing this, you know, forgot to do the times G bit. Okay, where are we off to next?
I was just wondering, this is about the midterm that we took like a month ago. I can't remember where the answers to that ever posted the solutions.
Well, let me show you where
I
they
mean,
are.
I was just thinking of going back and checking a couple
Yeah,
things.
sure. Nothing wrong with doing that.
Okay. Thanks.
I'm going to have to leave the student view for a second. Go back to home and I'll show you where I believe they are. And I'll have to go back in and it hasn't refreshed. That looks good. Midterm exam. Click on that guy. Midterm exam solutions.
Okay, is that under? Oh, it's under pages. Or
It's
that-
under its own module title. Let's shrink these guys up so we can see the module heading. There it
Oh,
is.
I see it. Okay.